my team at the University of Bristol has been supported UE to do this work. Hamid Falaki has been, and he is the AI expert working group secretariat. So can I say I really enjoyed the presentation, really brilliant work. And I'm so impressed for the breadth and the depth of the first report already. I mean, obviously you have many amazing experts in your working group. So if I would like to summarize and I make personal reflections, right? I haven't prepared this until I was hearing your talk. So some of the things that I take, AI for networks, and we are going to hear more and more on AI native networks. So I suppose we're looking forward to the second report to hear more what AI native networks are going to look like, but also networks for AI.
Yeah.
And you made that distinction from the very beginning, which I think is very important distinction to make because the two are quite distinct. They're not the same thing. So the other thing is that holistic view on cross-layer and cross-technology. And I mean, you clearly identify with your members that this is a real opportunity and probably is something that AI would help us to solve some challenges. And I'm sure that Tom is going to, to comment about this. And then, of course, regulation. Regulation is still in its infancy. But we start talking, because of data-driven services, about ethics and trust in networks. For me, that is important. I think for everybody it's important because that is mostly a new conversation for us. We talk a lot about regulation and standards, but not so much about trust and ethics. So that is going to come more and more important. And then, of course, the opportunity that comes with infrastructure. And in the UK, we have seen investment on AI supercomputers, as you mentioned in Edinburgh. There is one in Cambridge, actually, that has been announced, and one at Bristol. But these supercomputers, nobody mentions that there is an opportunity for telco infrastructure to leverage them. We are going to be producing enormous AI workflows if AI is adopted, and therefore we are going to be needed this kind of machines to process these AI workflows. So that is quite an exciting area, and that's my personal reflections. I don't want to take time. But the thing is that it's not only talking about AI. The important thing when we're looking at networks is how AI is going to be leveraged across the different technologies that we are using, critical technologies that you are using in the network. So today we chose 4 panelists, 3, including you, we are going to discuss with you the significance of AI in your technology domains. And I'm not going to reveal it because I'm going to ask you actually to introduce yourselves and your technology domains that you are working within UKTIN. So Dave, shall we go with you? You're first.
Sure. So it's Dave Happy. I'm chair of the Security Expert Working Group, and I have a headache. I'll explain why later.
Tom Bennett. I'm CTO at Freshwave, a neutral host provider, and I'm chair of the network management workstream, and I'm thinking on this panel probably the voice of the paying customer.
But who pay then, do they?
Allegedly.
Yeah, morning. I'm Simon Saunders, and I'm an telecoms advisor, but particularly of relevance today, I am chair of one of the sister or brother expert working groups alongside UE's, specifically the wireless networking group. So I'm keen to explore the intersection between AI and wireless networking.
Yue Wang, I'm the head of AI expert working group, and my day-to-day job is head of advanced network research in Samsung UK.
Okay, so Simon, when we are actually thinking about future mobile networks or current mobile networks, most of us, not me, I must say, think about wireless. And I wonder from your perspective and your group's perspective, what do you think is the opportunity, if any, for AI in wireless technology domain?
Well, I mean, I would say this, but I do think wireless networking amongst networking domains has particular need of AI as well as opportunity. And that that comes from something that Yue said in her presentation, which is complexity. Now, all telecoms networks are complex. Wireless takes that complexity and adds to it because of the complexity of the real world that radio waves travel through, the physics of radio waves, the complexity of the environment, overlaid with the complexity of all of the users moving, and all of the changes in the data demands that come from that. And matching the network to all of that complexity is a tough thing to do. And without AI, we've successfully built reasonably efficient wireless networks, but actually only reasonably efficient. And that's because in order to make the design and operation of wireless networks tractable, we have to make simplifications. We have to lock down parameters that could be varied. We have to assume things about the demands from customers, and we have to chunk up the processing pipeline into tractable little blocks or layers or whatever it may be, none of which is optimal. So AI, I think, for me, in wireless networking, offers opportunities really in three areas. One is in the link design, in the actual communication link, where actually doing that design rather than using codes that I sit and dream up on a given day, but by looking end to end at the flow of data from source to destination and finding what's the best way of mapping from bits to waveforms and back again, is one opportunity. The second one is in the design of the system as a whole. There's a lot to design in terms of the topology of a wireless network, where the antennas go, how they point in the right directions, and so on. And my own sort of background research domain of radio wave propagation prediction, I'm already seeing some fantastic results out of AI-based predictions. And then thirdly, in the operation of the network, and I suspect Tom will have things to say about this, as Yui said, any mobile network has many millions of parameters, very, very few of which ever get changed, because operators need networks that are also very reliable. And actually reliability is more important, and predictability, you say, is more important for those operators than optimality of those networks. So we leave most networks working very far from optimal almost all the time. And AI offers the opportunity to narrow some of that gap.
Okay, that's good. So with Simon, we have an AI enthusiast. That's a camp. Let's come to you, Dave. Do you actually share Simon's enthusiasm on AI from a security perspective?
I can answer that with a gesture. Well, I'd like to ask the audience something to see what response I get, to see if it's aligned with the thinking from my expert working group. I kind of suspect it will be, and then I'll broadly say why.
I don't know if this is allowed, but let's say it's allowed.
Yeah, let's say it is. That's a great idea. I mean, who said non-linearity was a problem? So what do you think the biggest problem of the security expert working group, what was it you think that they found in this domain? Anybody got any ideas? Oh, there's a gentleman at the front there that's just about to put his hand up that I didn't speak to earlier. Dean, what do you think?
I'm going to go completely off the rails and say identity and authentication.
That would be certainly right up there. And for that, and just to make it more interesting, you have won the Waterloo Belgian Beer Prize because I've just arrived from Brussels and I'm completely worn out. Congratulations, Dean.
Dave, definitely this is not allowed.
I know.
Serving alcohol in here.
You see, I think, however, there is a nice little serious point in that, because the beer I chose was Waterloo. And actually, from a security expert working group point of view, that's kind of where we're at. I thought of another great phrase that you could all take away, because although I may present in a fun way, there's a deadly serious point in most of what I do most of the time. Okay, the MC scene is not quite there for me. I'm more of an acid house and rock boy, but we won't go there, Dritan. What I would say is this. For me and for the working group that I chair, our problem is AI, heroin or aspirin. Because on the one hand, we can see the enormous energy, power and force and benefits that it could bring. On the other side, the withdrawal symptoms, if it goes even slightly wrong, would be catastrophic. And therefore, trying to get that balance right at a time when network operators are under phenomenal pressure is a really big issue. I'll limit myself and my 8 comments down to 1 so that everybody else gets to go now, Dimitri,
Yes.
and I'm a good boy. I think at a time when we're trying to run a policy in the UK of both sticks and carrots for security, it's very difficult for us to then go back to operators in the light of new legislation. And incidentally, I was in Brussels and some new legislation is coming out. DCIT from another department that doesn't talk to this department that we talk to is also doing some work on product security. Where did I bump into them? Etsy and Nice. So there's a genuine concern, and how we strike that balance between cost and the stick of regulation is of fundamental importance to me. Let's not even go into provenance, we'll say that later.
So we set up another camp between Simon and Dave. I was expecting this. Now, Tom, I really hope.
I am not following him anymore.
Yes.
Why you should.
Yes. I mean, you are leading network management, and I can see so many opportunities for AI and early entry, if you like, in our networks. So would you like to comment?
I mean, I'll comment and say I agree with both points and the themes. The themes here being complexity, technical complexity. I'll add to that technical complexity and say commercial complexity. What is a neutral host? Look, I'm here, I'm a CTO of a neutral host company. If you're looking at what network management is, it is that as a customer, I've been to a provider and said, I want an assured service. And therefore, how do we assure that service when somebody else owns the physical network, somebody else is probably owning the SIM cards and security, somebody else may be doing the core network. In this commercial complexity, there are often multiple providers and you don't know who they are. So yes, I absolutely see the benefit and the opportunity for both the technical complexity that Simon's talked about, and to your point, the secure complexity between these different agencies. Who has authority? Because the thing and the challenge I'd give back to AI, as well as supporting all of this, is being proactive. I come back to what's the raison d'etre of network management. The raison d'etre is we're being paid to assure a service. And in the future, waiting for something to go wrong, go alarm, fix it, is not good enough. Yeah. So the challenge I'd give back to AI and us, to be frank, as a community, as an ecosystem, is get ahead of that. I'm looking for AI to know and spot that it's about to go wrong and do something about it. But in that scenario, any changes have to be authorized.
Okay, so I don't even know if I have to, it's any point to ask next question, but I will go. So Yui, do you think that the telco industry is ready to embrace AI? Listening to your colleagues.
I would say yes and no here in the comments. I think if we remember, like 5 years ago, when we started to talk about deploying AI into the real network, there are lots of questions challenging, what about the security privacy concerns of AI, or what about reliability of AI models, whether AI can live up to the expectation, both in terms of performance and the investment, return on investment. So there are lots of questions and challenges, but we made progress, right? And we developed, for example, one compiling case is using AI for network energy saving, and that was actually delivering that real benefit to the network. And 2023 is a very interesting year because Gen AI came out, and there is suddenly this really widespread enthusiasm about embracing Gen AI. If you go to any of the telco conferences, like I think made to end of 2023, you'd hear more Gen AI than 5G, 6G. But and everyone was talking about that so enthusiastically. It just feels like the fundamental problems on, security, privacy, and this robustness of AI do not exist anymore. But they are still there. I kind of feel, we have had that 5 years to resolve some of the fundamental challenges on deploying AI to the telecom communication. We made progress, but it feels like, the issues we are talking about 5 years ago are still here today. So I think from that perspective, we seem to be embracing AI, but at the same time, I think we really need to look to tackle some of the fundamental challenges. And until AI is seamlessly integrated into the network, from operation to the services to the business, then I think we can say we fully embraced AI.
So if we continue with you, Yui, and you mentioned challenges. We can call them barriers. So if you want to name one, single big barrier that you see for actually deploying AI or adopting AI in networks, what that would be?
Yeah, I think I can see two. Data and the computational resources, I think those are the two initial barriers
Okay.
for AI development.
For networks,
Yes, for
because we are
particularly-
talking here for networks.
Yeah, for telecom networks.
So do you see that actually that is going to be a big cost in future network infrastructures?
Yes, I mean, yeah. So I was actually quite intrigued to see what is the cost to train a ChatGPT 4 AI model.
Yeah.
There are various sources on the website. There is one. The training cost on ChatGPT 4 model is $50 to $60 million in 3 months, and that 3 months is the duration to train the GPT-4 model, obviously using the most advanced compute infrastructure. So, and the energy cost is another issue because to train that model, the energy consumption was like 50 to 60 gigawatt hour. And just to put that number into context, we talk about using AI to save network energy, right? One of the operator talked about the energy that has been saved due to the use of AI, and that number is 63.2 gigawatt hours. Yeah, so to train AI, 50 to 60 gigawatt hour. The energy saved due to the use of AI, 3.2 gigawatt hour. But of course, that's not a fair comparison because, in the network, you don't need to always use really comprehensive AI because in a lot of times, reinforcement learning can do the job and it's much cheaper. And also, training is an initial cost, right? When the model is trained, the inference is actually much lighter. The cost on inference is actually much lighter. And also, think this as a initial investment, I would say, and to unlock the future capabilities. Of course, there is another option is we don't invest and we save the cost, but it's not going to stop the technology from evolving. I mean, if we don't do it, someone else will do it.
Thank you. Actually, you answered about 2 or 3 questions that I had, but that's good. We are coming back to the large language models. Because that's quite an interesting, if we have the time.
Yeah.
Tom, do you agree from a network management point of view, is actually for driving through management network automation, for instance, or predictive services, is going to be the cost of computational resource a big barrier for you?
Yes. I mean, in no uncertain terms.
But do you have a dimensioning of the problem compared to your current business?
No. I think, to be fair, at this point, Yo's going to be far more experienced on this. What I'd be looking for from this exercise, from the research exercises, is to support the telecoms ecosystem. We look at this, and for me, I'm looking at the set of challenges we have, just like every other business where you get the return on capital. So for me, very much, I mean, it's fascinating to hear those figures. That doesn't surprise me, which is, and I'll probably build a little on what Simon said earlier, we currently have a set of models, a set of business models. In particular, I'm thinking about the mobile ecosystem. And those business models, those commercial models, are predicated on pretty much something that's 35 years old. And yes, it's very much built around stability. I'll build on your point. I think between GSM was approved as a standard about mid-80s. The first networks launched in 1991, 6 years. 5G, I think it was more like 9 months. So that kind of innovation cycle I'm expecting to come through. In terms of this question, which is around, compute power, it's a fair question. I think as you look at this from a strictly mobile network, I'll keep it the mobile network perspective, who's paying? Who's going to pay for extra computational power? At the moment, you're about no extra revenue. Nobody here has talked about the extra revenue. There's potential cost savings. I get that. Are those cost savings going to champion that kind of investment in computational power? That's the challenge.
That's interesting, Simon, isn't it? Because the conversation moves of a network infrastructure to an IT infrastructure problem. I mean, if that's the case, how we can actually convince big players to invest in adoption of AI?
Yeah, I think that's a good point, because I think I'm going to sort of gently differ from what Yui had to say about the major barriers to getting the best from AI in the context of telecoms. I mean, I fully agree that the points you made are huge challenges in having AI generically working well, working efficiently. But I'm also simultaneously really confident that we'll evolve really fast down that path. There's an awful lot of people working on it. We know that you can do computation neurally far more energy efficiently, and it will have to be right size. Nothing will get deployed if it uses those sorts of volumes of energy. They'll have to fit within the current energy and financial budget for networks. The barriers are actually barriers that are old barriers. They're barriers that we saw 15 years ago when we were talking about SON in the context of early 4G, right, Tom? I mean, how much impact did that have? Well, we learned how to choose some cell IDs roughly automatically. Was the barrier to that not having great AI models? No, it really wasn't. It was organizational and operational barriers, the kinds of issues that I was alluding to earlier on, that you need certainty. You need to know your network is going to keep working. You need to provide the assurance that Tom was describing. There are ways of working, as you say, in the IT world that work there. I mean, I worked for a number of years for a large internet company, and I got to apply AI from there to some real operator networks, and that was really sort of educational, bringing together that IT world and that telecoms world. And the way those folks operate networks is massively more efficient in terms of personnel having to go in and tweak bits of networks. And that requires a really big mindset shift to happen. And I don't know, frankly, if telco can do that. I don't think it comes from that way of thinking about things. I think in some ways the only way you get there, and again I'm going to be sort of gently provocative here, I don't think existing telcos will learn how to do it from where they are today. I think you'll need greenfield telcos coming along and building networks completely differently. And then the best practices from that will come back into incumbent telcos.
I think there's a demographic inflection point as well. Let's be honest, the mobile engineers of today are all our generation. They all joined when they left university or started college 30 years ago. So I do think there's a demographic inflection point which will force the issue.
I'd add one thing.
Hopefully. Let's stay on the panel and then we... I mean, because I'm sure that this is a question that is quite interesting. So it all goes, from standard classical service provisioning over our networks to data-driven services. And Huey actually highlighted that in her talk. So if we are looking actually data and driving our whole infrastructure through data, do you think that by policing data, applying policies on data, that would solve also your key security problems?
Lovely question.
And you don't have it, you see?
Luckily, I anticipated that question and I have at least 8 answers to it. Again, it comes back to the stick and carrot approach. What you say is right, and I agree with Simon, SS7 still doesn't work properly. Maybe that's a good thing. But that's also an interesting point of itself. You're right. What I want to do is just make sure that we use this intelligently. And I think we suffer from a chronic over-optimism bias in our industry. And it's something that Simon said in the prep call that we did for this that got me thinking like that. And he said, we have all these acronyms and we invent something, and then about 3 months later we find something that's new and shiny and exciting, and we all get excited about that. The heat goes off a given topic. It doesn't mean to say in the case of AI, which I think is a more fundamental shift, and the ways that data can be used and mined for both good and nefarious purposes, that it's a bad thing. It's just a fact. My problem is that with all that data, who's going to be accessing it and on what terms? And if we go back to the UK, what we find is I think there are at least 9 different areas of regulation. of those, at least 3 of them are current. If we have any lawyers in the house, I would ask for show of hands, but I'm not going there. We don't have time. And I was discussing with UA how on earth you can actually make sense of this, because to Tom's point, on cost, it's an issue. There are duties that sit under the Telecom Security Act that make sure that even if it's a third-party supplier of a solution, you as the operator bear liability for that. And I don't think that that's been fully understood yet. And if you then overlay to that my problem is I'm dealing with a non-deterministic service that has non-linear characteristics, I can't predict, I can't easily put a wrap around it like I can for so many other things. That for me is the aspirin part of my problem. It doesn't mean to say that data isn't still heroin in a good way, in that I can do great things with it. But it doesn't mean to say at the moment that I'm comfortable that we're more than toddlers walking along and that we understand how to even fix some of the key security problems. We don't.
Thank you. So I don't remember myself to be on that prep call. Don't remember that prep call at all. But I wasn't
But it's
there.
not-
Yes, that's why I don't remember it. So going back to the statement that you made, that it was revealed now, Simon. Do you think that AI is a hype? Do you think it's actually a phase that is going to pass, and in 3-5 years' time we are going to be talking about something non-AI, or is here to stay?
So I actually hope that we won't be talking about AI in 5 years, but not for the reasons that it won't have succeeded,
Right.
but because it becomes assimilated. You know, we don't talk that much about digital radio anymore. Remember the digital radio? That's not because digital radio went away. It's because that's all of radio today. And I think, you know, we also don't talk about, oh, let's use some software in our networks, because they are built of software already. I think it'll be the same with AI. It'll just be how we build things, and we wouldn't then have conferences and discussions about AI. We would just have discussions about the things we happen to have built using that underlying technology. You know, that said, I mean, I think there is some of this that is more of a profound shift than some of those, you know, flavor of the month kind of technologies. A lot of it is really taking the human out of the design loop in ways that are, you know, slightly unsettling but exciting at the same time as a technologist, in that, you know, all the good things we did with OSI layers and all those things, they were really just devices to reduce complexity, to get it into our heads. You don't actually need those, and everyone brings an overhead. So I actually do hope that, you know, we get to that point that we're designing things in a very different way. You know, we're solving, you know, geometry problems, and we're solving physics problems today without needing the human brain in it. We shouldn't really need the human brain in every intricate step of the design of a network.
Do you agree with that, Tom? Would you actually ever design networks and deliver them without human in the loop? How would the future for your network management would look like?
I'm looking at the front and the back. So at the front side, as you're dealing with a customer, you're still going to need a human, right? No machines selling to machines yet. I don't think we're anywhere near that. So you're still going to need a very human element. I'd also say, look, just talking personally as an usual host, the operators are still very important, notwithstanding your point around the telecoms companies of tomorrow. The operators still have those control points where it's their network. And to Dave's point, there's certain regulations that stipulate that. Nonetheless, I agree with your point, which is, yes, I expect, for me, it's about the radio engineers of tomorrow will use AI in the way that you and I use spreadsheets.
Yes.
For them and the next generation of radio engineers, yes, in the way in which today I have an engineer and they'll do something like the Principality Stadium over the course of a couple of weeks. That's how long the design takes when you think about every physicality of that environment and cable runs and that kind of thing. Yes, I'm looking for AI can step in there and support the engineer and say, yeah, okay, here's the macro level coverage. This is what you need for 80,000 people, so on and so forth. I then look at the back end and build on Dave's point, which is when we're looking at how you do network management, and something very close to my heart, which is why does the customer pay us and continue to pay us? Yeah, there's one thing which is CapEx up front, there's another thing which is ongoing revenue. And they continue to pay us for an assured service. Now at that point, I do think it is about the observability, not just observability, can you action the data? Do you have the authority to action the data? And can you trace it? So at a point where a network management engineer is trying to work out what went on. Imagine the AI has been authorized, go make that change. And you've got to trace back as to why that caused a problem somewhere else. And I am now on about not just our industry, something that telecoms gets very carried away with is itself. Mobile World Congress, 50,000 people from around the world talking all the same stuff. I'll try and be polite. Yeah? Why? If we as a telecoms panel, as a telecoms ecosystem, are truly going to sell into other industries, are we talking to the car industry, aviation, trains, etc.? Give you a stat, okay? So just to embellish this network management point, what's the highest availability? I'll do Dave's thing. Anybody want to quote what the highest level of availability of a mobile network in the UK is? Or in fact, Western Europe, to be fair? Anybody want to hazard a guess? Availability of radio service?
Rural or non-rural?
Allegedly both.
Required or real?
Real, to be fair. I'll tell you this, it's not 5 nines.
Right.
All right? Put that into context, 99.9%. Everybody think that's really good?
No.
Yeah, I was going to say, because that's a crash a day at Heathrow. Yeah. So if we're going to do what we're all talking here as an industry, think about the customer. Are you really talking their language, and do you have the data to make the actions to keep it? I'm sorry, I've got 2 customers who are banks, and they don't even talk about 5 nines. The answer's always up. End of. So a bit of a long answer to your question.
Yeah, and I have to stop you here because we have to go to the audience. But first, I have a burning question. It is about large language models and networks. And we had a meeting more than 2 hours in our group the other day, and we completely argue with each other for the 2 hours. So I said, now we have an expert in the room, so I'm going to ask her. And my question is quite simple. If you see any role for LLMs in networks, what that would be and where? Yes, I mean, short question because we have to go to the audience.
Yeah, sure. I mean, what Tom was saying, you go to Mobile World Congress or TM Forum conferences, people are talking about the same thing. But I did actually see a demo using large language model built on top of the current ChatGPT. They build a wrap on top of it, and then they provide a demo to deliver the personalized services to a customer. So when you...
So that was sitting at the customer and the customer end rather than in the infrastructure embedded.
Yeah, not in the infrastructure. It's mainly like an interface to the third party.
Yeah, that's possible. We can have another panel when you actually release your next session of the report talking about this topic. But we have to open now to the audience. I'm sure that you have lots of questions for this experienced panel.
You and Simon can't see me, but they know what I look like. So point to you, which is not all gigawatts are equal. You can do the large language model training in Iceland on cheap power, and then the network has to run on when people need the power. So it's not quite as bad as you lay it out. And a question for Simon, which is, if the existing telcos can't get their head around AI, will we see the people who can get their head around AI, and I'm thinking your former employer, moving into the telco space and disintermediating the existing players?
Thanks, Simon. Yeah, I hope not, because telcos are actually good at being telcos and internet companies are good at being internet companies. There is quite a substantial overlap, because to build an internet company, you actually need to build an awful lot of infrastructure as well. And I think telcos have a lot to learn from how that infrastructure is built and run. How it can be done efficiently and reliably without being expensive. There's some magic in there, which does require questioning the way that you build stuff. They're fundamentally different businesses in terms of the dynamics of how you deploy capital, the returns you expect on them, the returns you actually get on them, and so on, and the skills involved. The overlap is large and becoming larger, but they are different businesses, I think. I mean, my job in said large internet company was to say, how can we help telcos networks using the technology we have? And I think that was a high quality discussion rather than the rather low quality discussions about over the tops and dumb pipes and all the rest of it.
Thank you. Oh, lots of questions. Can we go there, please?
This is a question for all of you, and I'm going to step back a little bit. Can you define AI for me? And the reason for that is that because when I talk to people, I get a very different view of what AI really is. And sometimes it seems to me that it's actually more machine learning. And it's just that, as someone says, this is flavor of the month. So whatever you do that has some software becomes AI. On the other hand, there is more of a, with Gen AI, some people equate AI to Gen AI and think that Gen AI is everything. So how should we think about it? And does it even matter? Because as Simon said, in 5 years from now, maybe we're not going to talk about AI and that will be progress, I think, as Simon said. So how do we define AI?
I guess that nobody is mixing in this panel AI with machine learning. But Huey, would you like to go first with?
Yeah, sure. We actually had that debate when we generated the report at the beginning. Let's define what exactly AI is. But the use of AI is so widespread, and the definition is so different, from the understanding of different people. But I think in general, it is about that intelligence you can bring to the network under the telco AI perspective. It's that intelligence and the automation that you can bring to the network, and especially based on the data that is fed to the model, and to be able to, for example, enhance network operational efficiency, reduce the cost. So that I think in general, that's AI.
Anybody else would like to comment?
No.
Okay, so that is the definition in our report. So put in context, because if you're reading an academic paper, for instance, there are clear distinctions of what people, computer scientists, for instance, or information engineers, they're actually naming AI or machine learning. But that's fine. That definition is absolutely fine. Anything that takes information and using the intelligent way is AI for telco, specifically for the telco sector. Right. Yes, Dean. Oops. I don't know where we go.
Where's the microphone?
Shall we go in front of here? Because Dean had his...
I'm reasonably loud, but I don't know
Yeah.
if people listening.
Hi there. It's very tempting to focus the telecoms AI discussion around the sort of deep in-network AI on the radio, or detecting earthquakes on subsea fiber or something like that. But what about the bit which we haven't talked about, maybe Tom a bit, which is the OSS BSS part of telecoms? I don't think there's even an OSS BSS group at UKTIN, but a lot of the work on AI seems to be, is that network management?
Yes.
Because it's not just the network though; it's the scheduling of engineers, and it's the sort of the external world, and as well the sort of billing and customer system. Is that where we see it first, or is it going to be deep in the network?
Do you want me to?
Yes, go for it.
So I suppose my view would be, yes, I'd actually expect to see optimization to your live network being the better benefit to the network operator, the quicker benefit. The optimization at the front end is part of your CapEx cycle. Yeah, so how do I build a network? Absolutely brilliant. That's going to be part of your commercial cycle when you're next investing in your network. I think AI coming forward as a set of products and services definitely to support how you operate the network and how you assure the customer that they're getting the service they want.
Is that including like the sort of the customer interface, the sort of
Correct, yeah.
AI chatbots and churn prediction and all that
You're
stuff?
into customer care then and CRM rather than the network itself. So I think you see some of that today.
Thank you. Shall we go? Oh, yes, okay.
To come back to the skills and talent topic, how do we get the right AI people and right AI capabilities into telecoms and not into something more exciting?
This is a very good question. Probably our panelists should answer, but we have a panel afterwards, or a fireside chat, that is going to be exactly for skills. But if anybody wants very quickly, yes, go.
A soundbite. I had on a previous DCMS DSIP program a PhD student attached to my business One thing we're trying to do is take people from different backgrounds. In security, I don't care how you're wired. I'd rather you were on a spectrum, maybe not Simon's, but A1. We need more people. I don't care how we get them. Your question is the most important of all. And thank God we've got some really good academics. And Dimitri, it's not often I say this, that definitely includes Bristol.
I'm sure always when you talk about good academics. So can we go back, please?
Hi, it's Roger Hinkson from UKTIN. It seems that the biggest problem from an R&D perspective is not that for security we don't actually have any. Could it be that we're not actually putting into practice what we talk about? And Tom mentioned that there's a lot of talking in the industry. Does the panel have a view on that?
I do. I
Go on
have
then,
a go.
Dave.
Okay, go there.
Go on then.
God, yes. In short, one of the key things that we found, it was one of our main conclusions, was that it wasn't that there was a dearth of really excellent R&D in the security domain, but there seemed to be an inherent reluctance to actually want to deploy it and use it. And if we can't get people to use it, then one way we can do that is by addressing some of the skills so that those that come forward become more willing to use it. But there's a real danger there, because how we can do all the research in the world, and I'll conclude with the Battle of Waterloo to finish off. The Battle of Waterloo was won for many reasons, but if we'd have gone into the field, we'd had a great R&D set up and we'd have given our guys machine guns and then no bullets, they'd have still all died. And that's what's at stake. What's at stake here, make no mistake, is whether our networks continue to function or whether they get taken down. And in the telco world, Simon well said, 5 nines and above, it had to be above. Tom said it has to be complete and all the time. But I'm now living in a world where people do things called software updates, and I'm really uncomfortable with that, because I need it to work all the time, and I need to know exactly on a linear way what's going on, and I don't. Great question.
Thank you.
And the chair usually does not actually argue with the panelist, but in this case I do, because I have completely different. If we are looking at AI, probably your argument actually is right for cyber, maybe not. But when we are looking on AI, R&D on AI is developing algorithms, a tool, sometimes fundamental maths to drive. The skills that we need in telecoms is not to do this. Somebody else is developing the algorithmic work. Somebody else is developing the AI solution. We are the adopters. So the skills are about adoption that we need in telecoms for AI. Is not so there is a huge role somewhere in maths departments, computer science departments, that they are actually driving the R&D for AI. And one of my colleagues, Julie McCann, should be here very soon from Imperial, that they're doing this kind of work. We need the skills for adoption. So it's a different sort of skills that we need when we are looking at AI. We have time for one more question.
I have the microphone.
Okay.
So I get to
I was
ask.
going to say, to be fair, that gentleman up there was waiting. Yeah, cool.
Should I yield to somebody? Is there somebody more interesting up there?
Go on.
All right. So I wanted to pick up on a point that Yuan made in her presentation, and also that Simon amplified a little bit about the separability of problem solving. So I mean, it's a well-established kind of human technique, right? If you've got a complex, multi-dimensional optimization problem, you try and separate it out into things that you can solve rather than things you can't solve. And I kind of buy the idea that within a radio, that actually that if you let the physical layer and the radio and maybe the link layer kind of work together, in an AI sort of learn the channel, that they could kind of work together to change the constellation and the whole physical layer. I mean, we don't even need to use those terms anymore. I feel that could work. But in terms of managing the network as a whole, surely you've always got things like traffic steering and neighbor relationships and power control, and those kind of things are always going to be separate problems. So aren't you always going to have patchwork solutions to things, even if your whole framework is kind of native AI?
Simon, you
Yeah, let me try. So I don't think those are necessarily intrinsically different problems. If you step back from it, your job is to deliver some bits from a source to a destination as faithfully and as efficiently as possible. And all of the processes that you mentioned are just subservient to that. However, it may be a really good idea to separate them, not because it will be more efficient, but because it will be manageable and you can buy bits of it from different people. And something like this, I wanted to comment on the sort of skills bit. We worry about reliability and sort of manageability of telecoms networks quite rightly, but we then make a false sort of step after that. That means every element of the network has to be totally understood and managed and individually reliable. The best way to build reliable systems is actually from a management layer on top of unreliable components. So there are good reasons for chunking things up, but I don't think it's because they are intrinsically different problems.
Thank you very much, Simon. And let us thank the panel. I mean, we finished at perfect time. So thank you very much.